here's the video for lesson 1-2 and 1-3, adding and subtracting real numbers. So the first three problems are pretty basic. 5 plus 8 is 13. Then we have fractions. So let's review how to do that. 3/4 plus 2/5. I'm going to rewrite it over here. In order to add fractions, we must have a common denominator. So looking at 4 and 5, the common denominator is going to be 20. One of the easiest ways to find the common denominator is to multiply the denominator. So 4 times 5 is 20. Now it's possible that there is a lower common denominator, but not in this case. So knowing that the common denominator is 20, I need to rewrite these fractions with that common denominator. So 3/4 is going to become 15 over 20, and 2/5 is going to become 8 over 20. So I multiplied 4 times 5 to get 20, and so 3 times 5 is 15. 5 times 4 is 20, so 2 times 4 is 8. Now I can add my numerators. 15 plus 8 is 23 over 20. I do not add the denominators. Keep the denominator the same. So 23 over 20 is my answer because 23 is a prime number. A prime number is a number that has only two factors, which are 1 and itself. So I cannot divide 23 by anything except for 1 or 23. That's a prime number. Now you'll notice that this is an improper fraction. That is okay. We do not want to write this as 1 and 3/20. We want to leave it as an improper fraction. All right, now let's take a look at this addition with decimals. All right, so we have 4.6 plus 9.73. Now, if you wanted to, you could have written the 9.73 on top. I'm going to go ahead and just put a 0 here to hold that place. So here we go. 3 plus 0 is 3. 7 plus 6 is 13. My decimal point is here. Carry the 1. So I'm going to go 9 plus 1 is 10, plus 4 is 14. So your answer is 14.33. Now, I want to point something out here. This does not mean that this is 1/3. Okay, 0.33 is not the same as 1/3. So just keep that in mind. Okay. Now we're going to look at the number line method for adding real numbers. When adding a positive number, move to the right on the number line. When adding a negative number, move to the left. Now, I gave you a number line here that you can label however you need to. I'm going to go ahead and put my 0 right, I'm going to do it in purple. I'm going to put my 0 right here. And this is going to be my -1, 2, 3, 4, -5, 6, 7, 8, and this is -9. And then my positive numbers would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Almost in the middle, so close. Notice I'm not labeling every line. That's really not necessary. Okay. So if I start at -3, then that means I'm going to put a dot there. Okay, this is my starting place. And then it says plus 8, so it means I'm going to move to the right 8 times. 1, 2, 3, 4, 5, 6, 7, 8. So where did I end up? I ended up at 5. So my answer would be +5. Okay, now let's look at 2 plus -5. So I'm going to start at +2 right here, and I'm going to move to the left 5 times. 1, 2, 3, 4, 5. Sorry if that was hard to tell. So where did I end up? I ended up at -3. -3. Starting at -4 plus -10. So I'm adding a negative. I'm going to be moving to the left. Now this is going to go off my number line. I know that for sure. So -4 is right, let's see, 1, 2, 3. -4 is right here, and I'm going to move 10 times to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, well that didn't really help me because I'm off the number line. So we need to try to make some conjectures about what's going to happen here, about what this is going to be. So hopefully we can figure out that the value of this is going to be -14. -3 plus -5 is going to be -8. So you can use this number line method to help you figure out what your value is going to be. Obviously, using the number line method for very large numbers is not going to be easy to do, and so we need to figure out what is the pattern or what are the rules that go with this. So write a rule for adding integers with different signs. So that would be like these two problems here. When the signs are different, let's see what happened. We went from -3 plus 8 and we got 5. Then we went from 2 plus -5 and we got -3. So if you notice here, when it's different signs and we're adding, we actually got the difference of the absolute value of the numbers. What is absolute value? Let's go over that really quick. Absolute value is the distance on the number line between 0 and that number. So the absolute value of -6, and I would write it like this. This means the absolute value of -6 is 6. What is the absolute value of 6? Also 6. The absolute value will always be positive. So if I subtract the absolute value of these numbers, 8 minus 3, or find the difference between these, the absolute value, I get 5. Well, why is it positive? It's positive because 8 was the bigger number and it was positive. Whereas down here, if I find the difference in the absolute value, 5 minus 2 is 3, but my answer is negative because 5 was bigger and it has the negative sign in front of it. Okay? So I'm going to let you write in that rule here. I'm not going to necessarily write that out for you. I want you to write that rule based on what we just discussed. All right. Now let's look at the rule for adding integers with the same sign. This one's really pretty easy. Look at the pattern. -4 plus -10, -14. -3 plus -5, -8. So what happens? Well, we are adding the absolute value of the numbers, and we are keeping the sign. Okay, this applies for positive numbers also, but I didn't feel the need to go over that. So that should be pretty standard. So -4 plus -10 is -14 because 4 plus 10 is 14, and they were both negative, so it stays negative. Right? If you start at a negative number and you move left, you're still going to be negative. That's what happens there. So again, you need to write in a rule for that. That should be in your notes. All right, let's move on to subtracting real numbers. Let's start with the easy ones. 12 minus 15, or maybe not so easy, I don't know. 12 minus 15, okay, think about it. We can really already think about our number line method. If I start at 12, what am I going to do when I subtract? I'm going to move to the left. So let's fill that in right now. When subtracting a positive number, move to the left. So what happens when we subtract a negative number? We are going to move to the right. So because we are subtracting, it is opposite of the sign. If I'm subtracting positive, I actually move left. If I'm subtracting negative, I actually move right. So if I'm at 12 and I subtract positive 15, then I'm going to move to the left, which is going to put me negative at -3. Okay, 3/4 minus 2/3. We talked about this earlier. 3/4 minus 2/3. What's the common denominator between 4 and 3? It is 12. 4 times 3 is 12, so 3 times 3 is 9/12. Minus 3 times 4 is 12, 2 times 4 is 8, minus 8/12. 9 minus 8 is 1, so you've got 1/12. That's your answer, 1/12. Then we have 12.06 minus 8.5. Okay, notice you need to line up the decimals. I'm going to put a placeholder there. 6 minus 0 is 6. 0 minus 5, I can't take away 5 from 0, so I'm going to borrow from the 2. Make that a 1, carry the 1. 10 minus 5 is 5. Can't subtract 8 from 1, so I'm going to borrow from this one, make it a 0, carry the 1. 11 minus 8 is 3. 3.56, 3 and 56 hundredths. So number line method, same concept, we're just moving different ways. So 5 minus 15, I'm at 5. I'm going to move left 15 times. That's going to put me at negative 10. You are welcome to use this number line and actually do the movement. I am not going to walk you through that this time. Negative 3 minus 5. I'm starting at negative 3, and I am moving left 5. That is going to be negative 8. All right, so here we have 4 minus negative 8. 4 minus negative 8. What do we do when we subtract a negative? We actually move to the right. Well, what is that like? Moving to the right is actually like adding a positive. So that's what's actually going to happen here. Instead of moving left, we're actually moving right. So 4 to the right 8 is going to be 12. And then here, we're starting at negative 3, but we're subtracting a negative, which means we're actually moving to the right, which is like adding. Which means we're actually moving to the right, which is like adding. So negative 3 to the right 10 is going to be 7. Okay, so we need to write a rule for subtracting integers. Okay, write a rule for subtracting integers. So here's what I want to tell you. We don't change the sign, which maybe you've heard before. What we do is we add the opposite. We add the opposite. So I'm going to let you write your own rule for subtracting integers. But I'm going to go ahead and model what I mean by adding the opposite. So in the example, 5 minus 13, what you can actually think of that we did is we did 5 plus negative 15. 5 plus negative 15. So now that we know that it's this addition problem, then we're able to apply the rules that we just talked about and go from there. So it's not a new rule, so to speak. Okay? Negative 3 minus 5 would be negative 3 plus negative 5. That's why it still is negative. 4 minus negative 8, I'm going to add the opposite. So that would be 4 plus 8. And then negative 3 minus negative 10 would be negative 3 plus 10. Let's take a look at this word problem practice. It says at midnight, the temperature was negative 12 degrees Fahrenheit. By noon, the temperature had risen 25 degrees Fahrenheit. During the afternoon, it fell 10 degrees Fahrenheit and fell another 3 degrees Fahrenheit by midnight. What was the temperature at midnight? So if you wanted to, you could draw a picture. Okay, here's my cute little thermometer. Let's see, we could make this 0. So what does it say? At midnight, the temperature was negative 12 degrees Fahrenheit. So I'm going to say this is 5, 10, 15, negative 20, 5, 10, 15. So these are negative 5, negative 10, negative 15. So I started at negative 12. By noon, the temperature had risen 25 degrees. So if I started at negative 12 and I rise 25 degrees, we're going to model that with addition. So we start at negative 12 plus 25. Let's go ahead and see where we end up. Negative 12 plus 25. Because I'm adding with different signs, I'm going to subtract the absolute values. I'm going to find the difference of the absolute values. 25 minus 12 is 13. The bigger number is positive, so it's going to be positive 13. So at noon, this is at noon. I'm at 13 degrees Fahrenheit, positive. Okay, then what happened? It fell 10 degrees. So I was at 13 and now it fell 10 degrees. So where am I now? I'm at 3 degrees Fahrenheit. That is during the afternoon sometime. Then it fell another 3 degrees Fahrenheit. So I was at 3 degrees. It fell another 3. So where am I? I'm at 0 degrees Fahrenheit. That would be your answer. And this is how you would model that with addition and subtraction.